Hi everyone. So today here we are going to have how to sketch a graph. So let me write it here, how to sketch the graph. So start to write. To sketch the graph here, to sketch the graph. All right, so maybe I did just take, all right, to sketch the graph. All right, so what do I need to sketch the graph? You have 4 steps here. Step number 1, you have to figure out, if you can, the domain here. So determine here, I need to determine the domain. All right, the domain of your f of x. So the domain of your f of x, that is step number 1. And here also we try to plot here any x-intercept, and that may exist. It might be there is no x-intercept, it might be there is y-intercept, and also indicate, try to indicate here, that is the 4th step here we are going to follow, and indicate any asymptote here, any asymptote. What is asymptote here? Asymptote here, it could be vertical asymptote or horizontal asymptote, that also that may exist. Okay, may exist. All right, so here, so that is, and then that's step number 1. I have to find the domain, x-intercept, y-intercept. I have to indicate any asymptote. If you have vertical asymptote, you have horizontal, you have to figure out. Step number 2, I'm going to apply compute, try to compute here f prime, the first derivative here, because the first derivative is going to find here, help us to find and plot all critical point, because that's the first derivative. Critical point, it could be singular point or it could be a stationary point, and indicate here, indicate f, the interval where f is increasing and decreasing, where f is increasing, where is your f is increasing and decreasing. Okay, so that is after we apply first derivative test, because that will help us to find the all critical point, and then we apply where is the interval f is increasing, where is interval f is decreasing. Step number 3, you are going to compute the second derivative. Usually most of the problem I will give you the first derivative after I simplify and second derivative after I simplify. So I have to compute the second derivative, and I need to find and also plot here all the point where that's all the point. This one I write it all the point, I write it in short. So I need to all the point where the second derivative is 0. What is the second derivative is 0? That is very much is inflection point. Okay, so maybe I just give a room for myself before I solve. So I'm going to just write the 4th step. So the second derivative is 0, and indicate also, try to indicate the concavity, right? Concavity, right, of f between this point, So very much here I'm going to this point, that is inflection point. So I between bracket I'm just write inflection point. So because your inflection point, that is a point where your second derivative is 0 or does not exist. Number 2, the point must be inside the domain. Number 3, the concavity is going to change before and after. Concavity, it change. So what is the last step? Step number 4 for the sketching the graph. We try to plot a few other point. So here sometimes other point, because sometimes the inflection point or critical point is not enough to sketch the graph. So between the critical point and inflection point, you can take more points so that your graph will be clear. So you have to plot a few other points if needed here. And remember, we need to sketch the graph. I'm not asking you to give me exact graph. sketch the graph, okay, or the curve, the graph or the curve. So that is the fourth step here I try to follow. So step number one, again, we try to find the domain, x-intercept if possible, y-intercept. Do we have asymptote here? Then we try to compute the first derivative to apply to find all critical point. And if you have minimum, you have maximum. And then we try to plot this critical point and we find the interval where f is increasing, f is decreasing. Step number three, compute the second derivative and find the inflection point. And then try to plot this inflection point and find the interval where f is concave up and concave down. And step number four, extra here, just to can take more point between the critical point or inflection point so that you will get x and y so that you can sketch the graph. Let me give you example number one here. Usually those four steps here, I will ask you like A, B, C. First, find the domain. Find asymptote if you can, and then I go one by one. So here, let me give you example number one here, how to sketch the graph. The question here is sketch the graph. Sketch the graph. What is here? What is the graph of f the functions What is that? It will be f of x equal to x cubed plus 3x squared plus 3x squared minus 24x and minus 20. I call this equation 1, and then I need to get, here is your first derivative. It's very easy to get the first derivative. Let me give you the first derivative after I simplify. So that is equation number 2. How did I just take the derivative and then I simplify for you here, give you f prime. So now I need to get the second derivative. What is my second derivative here? The second derivative here is, it will be 6x plus 6. You can check this one here, but I try to simplify like this. So just take normal derivative and you can show that is the first derivative here is correct and the second derivative here is correct, or assume that is given to you. All right, so now I need to sketch the graph for this one. So what is when I go for this for the function f of x, what is f of x here? F of x is polynomial, right? What kind of polynomial I have here? So if I go up here, it's a polynomial of degree 3, because the highest power here is 3. That is polynomial of degree 3. So what is the domain of any polynomial? The domain of any polynomial should be all real numbers. So that is our domain. So now sometimes you need to find x-intercept and y-intercept. How to get y-intercept? Y-intercept, where is the graph cross y-axis? Where is the graph cross y-axis? So I have to put x equals 0 in equation 1. And then if I look to, that is your f of x, that is your y, right? Your y equal f of x, that is what I have. If I replace x by 0, x by 0, x by 0, what did you get? Your y. Your y here is equal to negative 20, right? So if I replace x by 0, then this term becomes 0, this term, the first and second term and third term is 0, and what do you have? Negative 20. That is your y-intercept. X-intercept sometimes is not easy to find, because especially this polynomial of degree 3. So how to get usually, but is okay. As I said in the class here, you can skip this one here. I'm not going to give you the hard time for this like polynomial of degree 3 how to solve, because that is require maybe long division and it's really hard. So, but let me indicate how you figure out x-intercept. X-intercept, usually x-intercept, just you put y equals 0 in the equation 1. If I put y equals 0, you will get x cubed, the first equation, x cubed plus 3x squared, right? 3x squared minus 24x, and here plus, minus 20, right? Minus 20. So that is how to solve this one. You have 3 ways. One way is by testing, trial and error. What is trial and error? Trial and error. So which means you try x equal 1 and see which value here you can get 0. Try x equal negative 1, 2, negative 2. You just keep trying until you hit one value of x. If you put it here, then you are able to get 0, and then it will be kind of you do long division. So for example, if you have x minus c here, if c here, that is a value that equals 0. If I replace x here, you get 0. Then you write x minus c. So this one, it will be x minus c multiplied by something quadratic, which is x squared plus ax plus b. So that is 3 here, and that is, it will be linear multiplied by quadratic. You do long division. You have to do long division, or another way by graph. Sketch the graph here if you have graphic technology. Then you can see where is the graph cross x-axis, and that is the value here. That is your value where you have x-intercept. But here, I'm not going to give you, as I said here, hard time. So you can, it's called trial and error. But this kind of one here is, you don't need to worry about x-intercept or y-intercept. Let me keep continue, and I show you why I need x-intercept, because some people can ask why you need x-intercept, why you need y-intercept. I'm going to show you one by one. Okay, so now, do we have asymptote here? When you have polynomial, the graph of any polynomial here, that's polynomial equation number 1, is nice and smooth. So you don't have any asymptote. Asymptote means where is the function is undefined. Where is the function undefined? Here, if it's a polynomial, everything nice and smooth for any real value number, for any x, where x, it could be any real numbers. If I put it here, always you get value for f. So here I don't have any asymptote. You don't have any asymptote here, so you don't have VA or HA, because it's the graph here is polynomial, and if you have polynomial, everything nice and smooth. Okay, so that is very much the information you need from step number 1. I need to get the domain, y-intercept, x-intercept if you can, and then I need to have also what's called here is our asymptote, vertical asymptote or horizontal asymptote. That is polynomial, means the graph is nice and smooth. You don't need to worry about it. All right, so I go for step number 2. What is step number 2? From the sketching the graph, compute f prime. I give you first derivative. I need to find and plot all the critical point, indicate where f is increasing and decreasing. So how to get the critical point? That's the reason I simplified here for you. So if I look to the equation number 2, that's my first derivative. Also, this one, it's a polynomial, x multiplied by x, it's a quadratic here, or polynomial of degree 2, because x multiplied by x, you get x squared, it's a polynomial of degree 2. So your derivative here, I don't have singular point. We don't have singular point, because your derivative always exists for any real number x. You can try, is there any value for x? If I put it in my derivative, your derivative does not exist, it turned out no. So because for any value of x, real numbers, just I put it in my derivative, always you get value for your first derivative. So because of that, I don't have singular point. So no singular point. Okay, I don't have singular point. So now I have to go for the stationary point, because I need to get the critical point. So how to get a stationary point? Your derivative equal to 0, right? Your derivative equal to 0. When I say your derivative equals 0, just try to recall here, you may have something like this, or you may have like this. If you have the maximum, local max, then the graph should be like this, and that is where your derivative is 0. And here, if you have minimum, that is your derivative here equals 0. So, right? So that is, I'm just recalling. So equation number 2, that is my derivative, 3x minus 2 multiplied by x plus 4. So you have 3x minus 2 and x plus 4, equate that to 0. That is my derivative, right? I equate that to 0. How to solve this? Then you have 3 divided by 3. Then you have x minus 2. If I divide by 3, here x plus 4. And what did you get? You get 0 over 4. 0 over 3. 0 over 3, you get 0. 0 over any number, you get 0, right? So I get rid of 3 here. Divide both sides by 3. Then you get 0 over 3, you get that. So now how to solve? By 0 product. 0 product, if you have a multiplied by b equals 0, then your a equals 0, and also your b here equals 0, right? Or both of them are 0. Both of them are 0, right? So that is, so what you have here, guys, x equal 2, right? The first one, I should write it maybe one by one, x minus 2 equals 0. That is give you x equal 2. The second one, x plus 4 equals 0. Then that is give you x minus 4. So before I say they are a stationary point, I have to check they are inside the domain. Yes. What is the domain? All real numbers. So 2 inside the domain, negative 4 also inside the domain. So if they are a stationary point, yes, I need to get the value of that is your x equal 2. I need x equal -4. Then I need to get the value of y when x equal 2. What is your y? Your y here is the value f at when x equal 2. That is come from equation 1. Equation 1 here, if I go back up here, that is your y. If I replace x by 2, right, I need to get x when x equal 2. What is your y? Or what is the value of your f? Then go ahead and replace x by 2. So what do you have? Just replace x by 2 here. So you have here x, you have here x. So what do you have? You have just, you can use technology, and 2 cube, right? And here 2 square minus 24 multiplied by 2 and minus 20. So that is the one here. I'm just so 2x cube 3x squared minus 24x and minus 20. So if I use technology for this, what did you get here, guys? Just you will get minus 48, right? And this one, this value here, it could be minimum, it could be maximum after I apply first derivative test. So now when x equal -4, I have 2.2 and -4. So what is your y? Your y here is -4, which means negative. I go back to equation 1 here, and then replace x by -4. Replace x by -4. So what do you have? You have -4 cube, right? Plus 3 -4 square minus 24 -4. As you can see, I put -4 between bracket so that I don't do mistake. You can use technology here, guys. Let me give you the number here. I got 60. I got 60 here. Okay, so I got 60 here. So that is so that is 60, I think. So I hope it will be kind of correct here. The font I wrote it here is, yeah, 60 is correct. So that is when x equal -4. You have, so what is the point I got here? My critical point, xy. When x equal 2, your y is -48, and when x equal -4, what is your y? Your y here is 60. So here you have 2 point. You have 2 point here, guys. You have 2 point, -460 and 2 -48, and that is our 2 critical point. I need to plot this. If I look to the, but before I plot this, I need to apply first derivative test. I need to get the interval where f is increasing, where f is decreasing, right? I need to get f is increasing and f is decreasing. So here I need to apply first derivative test. So -2 here, sorry, -4 here, that's -4, and here is 2. So I need to get what happened for the sign of your first derivative, right? So what is your first derivative? Let me recall the first derivative that we got is 3x minus 2, x plus 4, right? So between 2 and -4, take any number you wish, x equals 0. Is that correct? Between 2 and -4, take x equals 0. If I replace x by 0 here, what is f prime of 0? You will get here, what you really care is the sign. You don't need to get the value. What is the sign? Is that positive or negative? What is the sign of your derivative? Is that positive or negative? So if I replace x by 0, that's 3 positive. This bracket, if I replace x by 0, you get -2, negative sign. And here, if I replace x by 0, you get positive, multiplied by negative, you get negative. So this one here is negative. So I have here is negative. So I put negative sign here. Negative sign means the function here is what? Is decreasing, going down. Right? So between 2 plus infinity, take x equal, say, 3. Right? So if I replace it here, I really care about the sign. 3 plus 4, it's a positive. 3 minus 2, positive. So positive times positive, you get positive. And here positive. So here you have the function here is positive. Your first derivative is positive. I write plus. And then the function here is what? Is increasing. And last one here, take x equal -5. Then if I put here x, this bracket, -5 plus 4, -5 plus 4, you get negative sign. -5 minus 2, it's negative. So negative times negative, you get positive. So this one here, you get positive sign. So what do you have? This one here is increasing. So the function is going up before -4 and then going down because it's decreasing here. So what do you have here, guys? Yes, I'm hearing. So local max. So you have at -4. So you have local max. What is the value of your local max? X equal -4. And what is the value of your f? Your f here we figure out 60. So that is, so this value 60 here, that is the value of your, that is the value of your maximum here, guys. All right, so that is the value of our maximum here. All right, so what is the value of your f? 60 here when x equal -4. So what about 2? When I go for 2, you'll find before 2 the function is decreasing. You have arrow here down, and then you're going up. So here before 2 you're going down and go up. So what you have local min, you have local minimum, and then just write the minimum when x equal 2. You have your y equal -48. -48, that is your local min. Okay, so now I figure out local max, local min, and even I figure out the interval where f is increasing. F is increasing where, just write the interval here, guys. F is increasing, so f is increasing here, is increasing, right? So just let me write it here. F is increasing. All right, so when you have, look to here in the interval from -infinity to -4, that is increasing, -infinity to -4, and also from 2 to +infinity, from 2 to +infinity. So I should write here from 2 to +infinity, right? So where is f is decreasing? F is decreasing here. F is decreasing between -4 and 2, -4 and 2 only. So -4 and 2. All right, so far I have 2 steps. I need to collect those 2 steps to sketch the graph. All right, so let me sketch the graph. So in order to have that, of course, when I have something like this, and the final exam, I give you like sheet graph so that you can scale it proper. You have proper scale. So right. So now that is your x, right? So that is your y. I said here, if you look to up here, is the when I start, I tell step number 2, compute f prime, find and plot. You have to plot. So here is our plot, all critical point, and indicate where f is increasing and decreasing. That is step number 2. So here, if that is our graph, all right, so what I need to do, I have to figure out which is -4 and 60, -4 and 60. So when x equal -4, your y equals 60. So if that is -4, then if that is 60 here, remember I need to sketch the graph. So -4 and 60, that is where I plot. What do you know about at -4? You have what? You have stationary points. So the graph should be like this. And you have maximum, right? You have maximum here. So at 2, when you have 2, what is your value of your local min? -48. -48. So I have to go back here. So that is maybe -48, 2, and -48. That's the one. What do you know about this point? You have minimum. You have minimum, right? So you have minimum. So that is, look what you have, guys, here. You have horizontal tangent here. As you can see from the graph here at 2, what happened for the function is the function is decreasing, going down. After 2, the function going up. So here I should have, yes, here look what you have. That's decreasing, going down here, and then going up here like this. So that is increasing. The function here is increasing, and then the function here is decreasing, right? So, and here, before -4, what happened for the function? The function here is increasing, and here after -4, or after this one here, the function is decreasing, going down. So here going up and then going down. So far, that is what the information I have. So I have to go for step number 3. Step number 3. What do you know about y? Y-intercept. I said y-intercept is what? This one here, -48, right? When x equal 2, your y is equal -48. So that is the point. So that is maybe -2. So what do you know about -2, guys? -20 here, -20. That is your y-intercept. So your graph cross y-axis at -20. At -20. Look what you have up here. When I start the problem. Here, I said y-intercept. How to get y-intercept? I both x equals 0. I get y equal -20. So means your graph cross y-axis at -20. So that's what I did. So now if you know x-intercept, then you will, okay, that's a point, maybe here x-intercept, so you will know what is the value, then you can graph cross x-axis. You can graph cross x-axis. I have not finished yet because I have to connect this graph, whatever I have here. So how to connect it? I have to go for step number 3. What is step number 3 telling you? Step number 3, I tell you compute second derivative. What is my second derivative? 6x plus 6. So now I need to compute the inflection point. The inflection point, right? So what is the inflection point? If I ask you for this, what is the inflection point? Inflection point, that is where your second derivative is equal to 0 or does not exist. Look what you have, your second derivative, it's a polynomial of degree 1. Polynomial of degree 1 means your second derivative always exists for any real number x. Always exists for any real number x. So now your second derivative could be 0. So if your second derivative is 0, you get 6x plus 6. If I go ahead and solve this, you have take 6 to the left. You have -6. What is x? Your x equal -1. Your x equal -1. All right? Is -1 inside the domain? Yes. -1 inside the domain. So yes, x inside the domain. I should write inside the domain. The domain of what? The domain of your f of x. The domain of your f of x, which is all real numbers, all of them. So -1 inside the domain, that's condition number 2. It's condition inflection point. I'm just kind of reviewing. Inflection point, your second derivative is 0. I solved that. I got x equal -1. This -1 must be inside the domain. Condition number 3, I have to check concavity before -1. What happened for the sign of your second derivative? What happened for the sign of the second derivative? So I look for the sign. Always I look for the sign of my second derivative. All right, so what is your second derivative? Here is your second derivative. Your second derivative is 6x, all right, 6x plus 6. That is our second derivative. So I'm just looking for here. So let me go up here a little bit. So your second derivative here is, that is our second derivative, 6x plus 6. So before -1, take x equal -2. Say if I take x equal -2, then what is your second? What is the sign of your second derivative? If you take -2, 6 multiply, replace x by -2. 6 multiplied by -2, you get -12. -12 plus 6, you get negative number. So here my second derivative is negative, means the graph is what? It's concave down. Concave down. So now if I take after -1, for example, I take x equals 0, because 0 before -1. What happened for my second derivative? If I replace x by 0, you get +1. Positive, your second derivative is positive. Then the graph here is concave up. The graph is concave up, right? The graph here is concave up. So now, is this one inflection point? Yes, because the concavities change from concave down before -1, it changed the concavity from concave down to concave up. So now I need to get the inflection point, right? How to get the inflection point? So -1 is inflection point, yes, but I need to get y. So what is your y? When x equal -1, I have to get y, which is the value f at -1. F, your y. When x equal -1, I need to get the corresponding value y. So I have to go to equation 1. What is equation 1? Your f of x up here. So that is, so here, equation 1. Just go ahead and replace x by -1. Then you are able to get the value of x. So here, I go to equation 1. So you have -1 cube, right? -1 cube plus 3 -1 square minus 24 multiplied by -1. And here -20, right? So now, if I use technology, you get -1, here you get 3, and here you get plus 24, and here you get -20. All right, so what did you get? You get just number 6 here. So what is my inflection point? The inflection point, all right, so it's just when x equal -1, your y is 6. Right? When x equal -1, your y equals 6. Then I have to go, where is the interval? Where is f is concave up? The interval where f is concave up. And where is the interval? The graph is concave down. Look what you have. From -1 to plus infinity, that is where the graph is, the interval, -1 and plus infinity, the graph concave up. Where is the graph concave down? from minus infinity to negative 1. From minus infinity to negative 1, that is the graph where f is concave down. Okay, guys? So here it's kind of review all what we have learned from this chapter here. Apply first derivative test. Apply where is the interval f is increasing, decreasing. Here, where is f is concave up and concave down. So now I have to take this point and I have to plot that on the graph, negative 1 and 6, all right? So maybe I use different colors, red or something, so that you can see the difference. So I have to go back to the same x here. When x equal negative 1, maybe here negative 1, right? What is your y? Your y here 6. So what is the value here? That is 60 here. That is 60. So maybe 60 here. So that is a point, and maybe I put the point here. That is negative 1 and 6. That is our inflection point. Okay, what do you know about the graph before negative 1? The graph is concave what? If I look to up here, the graph is concave down. The graph is concave down. So before the negative, concave down. So I have to, before negative 1, the graph is concave down. So I have to link, that is the one here. Look what you have. So this one here, the red one, it's concave down here. Look what you have. I make it, that is concave down. Yes, it's concave down. Right after negative 1, the graph is concave up. After negative 1 here, the graph is concave up like this. So it will be kind of concave up. So this one concave up before negative 1, concave down. Look what you have. The graph before negative 1 concave down, and after 1 negative up. Right? So that's very much the sketching the graph. I combine step 1, step 2, step 3. Step number 4 that I mentioned here, sometimes they tell you take more point. Look what you have. Where is the step? When I started writing the summarize, step number 4, they tell you plot few other point if needed to sketch the graph. Let me explain what I mean here from this. If I make a table here, what are done here as up to here is okay. So you have x and y. What is your inflection point? Your inflection point negative 1 and 6. Right? What is your, that is our inflection point. That is our inflection point, right? That is our inflection point. So what do you have for negative 4, and you have 2, right? So that is our stationary point. So what is here? You have negative 48, and here you have 60. That is our, this one here, our stationary point or critical point. Stationary point or critical point, right? So now, sometimes between negative 4 and negative 1, the graph is not clear. Look what you have here. Maybe it's clear. If I go up between negative 1 and negative 4, you could add some point like negative 3, negative 2. Maybe I use different colors here. This one here, blue. I use blue. So you may have adding negative 5 here. Between negative 4 and negative 1, you could add negative 3, negative 2, and then you find the corresponding value for y. Likewise here, you could get more point 2. You could maybe write 3 or 5 here, 5, or take more point 6 and so on. So you go ahead and find the value when x equal 5. What is your y? Just to get more point, so that when I go back to the graph, you can see the graph. It will be like something like this, and here going down like this, right? So this point here, if you are able to get x-intercepted, then it will be fantastic. But sometimes it's hard, like this problem. Then what you do, take more point. That is when x equal 2. So what about when x equals 3 or 4 or 5 or 6? Then you can figure out the point like this. All right? So that is when I say step number 4, you get more point. But up to here, I'm happy because if you consider step 1, 2, 3, I'm happy because that is enough. You apply first derivative test, you find the inflection point, you find your domain, you find your asymptote if you have, then you are able to finish the problem. Okay, I hope it will be kind of clear here, guys. So this one here, it's easy one, but let me give you another example here. Example number 2 here to solve one problem here. So if I go for number 2 here, all right, so I'm just looking for example 2. So here, guys, example number 2, you have f of x equal to x squared minus 1. Try to see here, x squared minus 1 over x squared plus 3. What is my first derivative? The first derivative here, I'm going to give it to you after I simplify, which is 8x over x squared plus 3 squared. What is my second derivative? Your second derivative is, I'm going to give it to you here. It will be kind of 24, 1 minus x squared over 1 minus x squared, right? So divided by x squared plus 3 cubed, all right? So how did I get, that's number 1, number 2, number 3. How did I get the derivative? Here you take the first one, apply quotient rule, right? So, but in the exam, if I do that, I will give you the simplified, similar to this. I tell you f of x, first derivative, second derivative. But for you, for the sake of practice, go ahead and apply quotient rule. That is f over g. How to get f over g? Then it's quotient rule. You apply twice quotient rule, f over g prime. It will be g squared g f prime minus f g prime. All right? So now, step number 1, if you recall, I need to get the domain. All right? I need to get the domain. How to get the domain for x squared minus 1? What is the domain? First, you have a fraction here. You have a fraction. But what do you know about x squared plus 3? What do you know about x squared plus 3? X squared, you see, guys, I tell you, whenever you have a fraction, you should worry about to have something x squared minus 1 divided by 0. Because we cannot divide by 0. If you are able to divide by 0, means the function will be undefined. The function will be undefined, right? So because of that here, guys, I have x squared. I have to figure out x squared plus 3. What do you know about x squared plus 3? X squared plus 3, it's always positive. Always positive. This one positive for any real number x. Let me show you. For any real number x. Let me show you. If you take x equals 0, guys, x equals 0. What happened for x squared plus 3? You get 0 squared plus, replace x by 0. You get 0 squared plus 3, which is 3. That is positive? Yes. If I take x plus or minus 1, then what is the value of x squared? Replace x by plus or minus 1 square plus 3. So here, if you have 1 plus 1 square, you get 1 plus 3, you get 4. Negative 1 square, you get also negative 1 square, you get 1 plus 3, you get 4. So that is greater than 0. So both of them here, they are greater than 0. So here, x squared plus 3, it's always positive number. So like here, when I go for this fraction, then I'm not worried about x squared plus 3 because it's always positive. So I'm not worried. There is no value for x. If I put it here, I can divide by 0. You will figure out your f of x. It's always defined. There is a value for, if you take x equals 0, what happened? What is the value of f? You get a value for f. X equal any real number you wish. Then you get always there is a value for your f. So because of that, x squared minus 1 over x squared plus 3, it's like polynomial. Because x squared plus 3, it's like positive number multiplied by x squared minus 1. Positive number multiplied by x squared minus 1. Right? So that is so here it's, which means the domain of this, all real numbers. So let me explain the domain of your f is all real numbers, all of them. Why? Because x squared plus 3 equals. So now I'm just write it as a remark. What happens if I give you the same problems, but you have your f of x equal to x is what you have up here. Here x squared minus 1. If I repeat the same problem, x squared over x squared minus 3. If you here I replace negative in the middle between what you have, I give you in the middle plus. So that is the reason we said x squared plus 3 always positive and always exist. Now, if you take x squared minus 3, so I ask myself, is that possible to have x squared minus 3 equals 0? Yes. That is, let me show you here how to solve this one. You can use quadratic formula. Then what do you have? Or I solve this one like this, x squared plus 3. So what is your x? Plus or minus square root of 3. So plus or minus square root of 3. So that is the value. Make x squared plus minus 3 0. So what is the domain for this case? The domain of this one here should be all real numbers, except these two value when x equal plus or minus 3. So those two value here, negative and positive, that is not in the domain. And my f is undefined. Your f here is undefined. So that is, and that is now x squared, x equal plus or minus 3 for this example here. If I ask you, do you have vertical asymptote? You know, just let me explain. I'm just here getting out of the problem, but it's okay. So here, how to get the vertical asymptote here? Vertical asymptote. How to get vertical asymptote here? So the vertical asymptote here for this problem. So when you say vertical asymptote here means you have a vertical line. How to get vertical line? So let me ask you, when you have a vertical line, is that x equal constant or y equal constant? X equal constant or y equal constant? It's clear x equal constant. When x equal a. When x equal a, that is our vertical line. That's a vertical line. So vertical asymptote means x equal a. So for this example here, for this remark here, I'm just writing remark. So if I ask you find for this example here, find VA, vertical asymptote, then that is your asymptote here. So your vertical asymptote plus or minus, I have two of them, plus or minus square root of 3. Plus or minus square root of 3, right? So that is our vertical asymptote. Vertical asymptote means you have vertical line. How to get vertical line when x equal constant? When x equal constant, that is a vertical line. So which means if I use technology for this, then you have vertical line at square root of 3 plus, and at negative square root of 3 you have vertical line. So means your graph never cross or touch these two lines. All right. So that is just kind of remark about the domain and our VA. So now we return back to our example. Our example here, example number 2, I need to sketch the graph. But here, x squared minus 1 over x squared plus 3. Then I give you some remark about if here for this, our example here, the domain should be all real numbers. Why? Because x squared plus 3, there is no way to get that is 0. If some people can return back, so my remark is, so return back to the example, your f of x equal to, what is your f of x? It will be x squared, right? It will be x squared minus 1 over x squared plus 3, right? So now we figure out the domain. Because of this one, it's always positive. Some people say, what about if I take x squared plus 3 and I try to check if this one could be 0 or not? Use quadratic formula. If you use quadratic formula, you will figure out this quadratic formula does not exist. That is our quadratic formula. So what is your A? Your A equal 1. What is your B, guys? Your B, I don't have any x. Do you have, what is quadratic formula? AX squared plus BX plus C equals 0. So what is your A? 1. What is your B? You don't have B. Your B here is 0. What is your C? Your C here is 3. Right? So if I use quadratic formula, I don't have x here. So that is the reason the coefficient of x here, this one, it will be your B here is 0. If I use quadratic formula, you will get negative b, which is 0, plus or minus square root of b squared, which is 0 squared, minus 4a. What is your a? 1. What is your c? 3. The whole thing divided by 2a, which is 2 over 1. If I look to this one, it will have plus or minus square root of negative 12 over 2. Square root of negative 12, when I use technology, means you have error. You have error, means this value does not exist, which means this one, if I'm not able to solve, there is no real solution, no real solution, means this one cannot be 0, because when I assume it's 0, it turned out impossible to have that is 0, because I have a square root of negative 12. When you have a square root of negative something here does not exist, it means it's not in the domain, or this equation unsolvable. I am not able to solve this equation, means it's non-zero. All right. There is no such value x could be 0, right? So that is something here. It's very return back to this example here. So that is our domain. So now I need to get for this our x-intercept and y-intercept, right? And then I need to figure out x-intercept and y-intercept. And then, so what is the x-intercept and y-intercept? So that is your f of x. That can I call it y? That is equation 1, right? The same one is up here. So now, how to get x-intercept? X-intercept, guys, x-intercept. I need to get x-intercept. Where is the graph cross x-axis? That is when y equals 0. So if I put y equals 0 in equation 1, look what you have, equation 1, x squared minus 1 over x squared plus 3. So you have x squared minus 1 over x squared plus 3. So now let us recall, if you have a over b equals 0, then what is your a? Your a should be 0. What about your b? Your b cannot be 0. Your b cannot be 0, right? So I have b. If you have a fraction equals 0, then always you take whatever you have up, that is the one it could be 0. The one that is down is non-zero. So now, so what is your x here? Take whatever you have up, which is 0, equal x squared minus 1. Now I use quadratic. You can use or factor, right? So you can factor this, x minus 1, x plus 1. Then use zero product. So your x equal 1 or your x equal negative 1. So those two values, what? That is where the graph cross x-axis. That is, it's easy to solve compared to the previous example. Previous example, it was hard because it's polynomial of degree 3. But here it's easy, x squared minus 1, you have 1 and negative 1. That is our x-intercept. Now, what is your y-intercept? Y-intercept is 1. I have to put x equals 0 in equation 1. So if I put x equals 0, where is equation 1 here? Look what you have. Just replace x by 0 here, replace x by 0. So what did you get up? Negative 1. What do you have? Down 3. So I get negative 1 over 3. Right? So that is our y-intercept. The graph cross y-axis at negative 1/3. Right? Negative 1/3. So if I replace x by 0, this term, what do you have up? Negative 1. If I replace x 0 down here, what do you have? You get 3. So negative 1 over 3. So negative 1/3. That is y-intercept. So now I need to get VA, vertical asymptote. Right? So how to get your vertical asymptote? Do we have vertical asymptote? So vertical asymptote, if you have your f of x equal to x squared minus 1 over x squared plus 3. Always, in order to get vertical asymptote, always you take whatever you have down here, and that is the one should be 0. But in our case here, x squared plus 3 cannot be 0. Cannot be 0, right? X squared plus 0, x squared plus 3, always positive number. I'm just explaining to you. It's always here. Look what you have here. Always positive, where I explain this one here. So x squared plus 3 here, this one here, I explained it's always positive. So because of that, there is no way to have x squared plus 3 equals 0. So because of that, there is no VA, no vertical asymptote. I don't have, there is no vertical asymptote. Okay, guys? Because so the vertical asymptote, always when you have a fraction, you take this one, equate that to 0, and that is the value where you have, it's called vertical asymptote. All right, so I don't have vertical. So now, do we have HA? What is HA? HA here, HA means horizontal asymptote. Let me show you here. I'm just reviewing a lot of stuff. Horizontal asymptote. Well, how to get, what is horizontal asymptote here? So now, horizontal asymptote here, is that a line? Yes, horizontal line. How to get equation of horizontal line, guys? How to get equation of horizontal line? So in order to get the equation of horizontal line, just let me show you here. In order to get equation of horizontal line, is x equal constant or y equal constant? It turned out y equal constant. Y equal constant. Y equal constant. So the question here is, I have to take the limit. In order to get horizontal asymptote, take x close to plus infinity or minus infinity. One of them could be plus infinity or minus infinity for your f of x. What is your f of x here? Your f of x here, that is your y. Your y, right? So that is your y. So your y plus or minus, that is your y. If it turn out you have a constant, the constant, then y equal b, that's the constant. That is, you will be your HA, your horizontal asymptote, right? So what do you have for horizontal asymptote here? It will be limit x close to plus or minus infinity. What is your f of x? X squared minus 1 over x squared plus 3, right? So when x close to plus infinity or minus infinity, that's chapter 10, then you have to go back and take the leading term. What is your leading term here, guys? What is your leading term? Leading term up x squared, the highest power x squared. What is the leading term down x squared? So what did you have? X squared cancel with x squared, you get 1. What is the limit of any constant? 1. You get the same, which is 1. So now, what did you get? You get y equal 1. So that is your y. This one here, that is your f of x. F of x is what? Is y. f of x is y, and that is turn out equal constant b. What is your b here? B here is 1. Our b here is 1, so y equal 1. So that is our HA. That is our HA. Okay, guys? So that is our, now I need to collect all this information to put it that on the graph. So on the graph here, but maybe I will, you have, here is the graph. Maybe I do that here. All right, so here is the graph. So that is your x, and that is your y. So now, what is your y? Y equal 1. That is horizontal asymptote. So I have to make a horizontal line like this. Just y, it's a line, should be dash line. Dash line with laser, y equal 1. That's horizontal line. So that is our HA. I don't have VA, so I'm not worried about it. Where is x-intercept? X-intercept is -1. Look what I have here. The domain or real numbers. X-intercept 1 and -1. And your y-intercept -1/3. So I know from the graph, -1/3 may be here, -1/3. So I know the graph should be cross, that is your y-intercept. And here you have 1, and here you have -1. So that is the graph is going to cross here, -1 and 1, right? So -1 and 1, and here, so -1/3. So that is the information. I plot all this information. What is our asymptote? What is our x-intercept, y-intercept? And that is step number 1. Step number 2, they tell you, if I go back up here, step number 2, they ask you to compute first derivative, and we have to find the critical point and plot them. So how to get the critical point? So that is step number 2. Step number 2, sketching the graph, how to get the critical point. The critical point here is your derivative. What is your derivative here? I'm just copy our derivative. You have 8x over x squared plus 3 squared. So that is our derivative, right? All right, so now, do we have singular point? No singular point. Why no singular point? Because your derivative always exists for any real number x. This term, it's always positive and non-zero. Positive and non-zero. So this derivative always, if you take x, any real number you wish, you will put it there, you get always value for your first derivative. Then if there is a value for your first derivative, then you're no singular point, right? So now how to get stationary point? Stationary point, that is the one I need to, stationary point. So you take your derivative, equate that to 0. So here is your derivative, 8x divided by x squared plus 3 squared, equate that to 0, right? So now what do you have? You have a fraction. You have a fraction. Again, if you have a over b equals 0, a over b equals 0, then your a must be 0. Whatever I have up, your b cannot be 0. Your b cannot be 0 because we cannot divide by 0. So here, 8x equals 0. 8x equals 0. Then how to solve this one here? Divide by 8. You get 0. So x equals 0. So x equals 0 inside the domain? Yes, because the domain all real numbers. So here, x equals 0. Yes, inside the domain. The domain, what is the domain? All real numbers, right? So that is, is this one a stationary point? Yes. I need to get the value. That is, what is your y? F at 0. F at 0. So I have to go equation 1. Equation 1, where is equation 1 here? That is f of x here. Where is f of x here? Here, equation 1, x squared. Just replace x by 0, guys. If I replace x by 0, what did you get? 0, 0. You get -1/3. -1/3. That is like your y-intercept. -1/3, right? So x equals 0. So I got here your y is -1/3. Your y is -1/3. Okay? So -1/3. So now, what is my critical point? 0 and -1/3. This one here is, that is my critical point or stationary point. -1, 0, and negative. So when x equals 0, I go back to your f to find what is the corresponding value for y. It turns out is -1/3, and then that is your, what's called here is your negative. So now I need to apply first derivative test. So here is your 0. I have to look to the sign of f prime, the first derivative. All right, so what is your first derivative here? That's your first derivative, 8x, equation 2, 8x over x squared plus 3. So before 0, guys, what do you know about this term, guys? What do you know about x squared plus 3 squared? This term always positive, right? Always positive. So I'm not worried about this term because it's always positive. This term always positive. positive here. So I'm worried about 8x. What is the sign of your 8x? Right? So if I go back to here, if I take x equal -1, 8x, it will be -8, negative sign. So here is negative, means the function here is what? Is decreasing. So now when I take x equal 1, then your first derivative is positive because 8x, 8 multiplied by 1, you get positive 8. So here positive. So the function here is what? The function here is increasing. The function here is increasing. All right. So now what do you have? The function is going down and then going up. So what do you have? Local what? Local min. Local min, right? Local minimum. I have local minimum. And what is the value of your local minimum? Your x equals 0. And what is your y? Negative 1/3. So that is our local minimum, right? So now if I go back here, guys, here, so I have local minimum, right? I should maybe extend this graph. So what do you have? So if I have here, all right, so here, if I make here negative 1/3 like this, then I have local minimum like this. But you know, the graph is cross, that is your x-intercept. Look what you have. So the graph here should be going up like this. Why? Because you have horizontal tangent here. That is negative 1/3, right? So that is your x negative. So here, what is your x, guys? Your x here is 0. What is your y? Negative 1/3. So negative 1/3. So you have like here local min, that is your minimum. And you have x-intercept. The graph cross x-axis at -1, cross y-axis at -1, and likewise cross y-axis at negative 1/3. That is your y-intercept. Y-intercept negative 1/3, right? So now it's very much, you are almost done, but I need to compute step number 3. What is step number 3? Step number 3, guys, here. Step number 3, I have to use compute second derivative. What is your second derivative? The second derivative here, maybe I just write 24, 1 minus x squared divided by x squared plus 3. So that is here 3. All right. So that's come from equation number 3. It's given to you after I simplify, or just you apply quotient rule 2 times. Apply first time quotient rule to get the first derivative, and then apply quotient rule again for the first derivative to get the second derivative, right? You are going to apply quotient rule twice. And if you have difficulty, just see me there, right? Or just let me know. All right. So now 24, 1 minus x squared over this. So now I need to get the what here, guys? Inflection point. Inflection point, right? So how to get inflection point? Inflection point here is your derivative. Is there any value for x? Your second derivative does not exist? No. Why? Because this one here, it's always positive and non-zero. This one always positive and non-zero. So now your second derivative could be 0. That is the only way. Second derivative equals 0. Then if I equate the second derivative 24, 1 minus x squared over x squared plus 3 cube here, cube equals 0. Again, you have a fraction. You have a fraction. If you have a fraction, I'm just repeating this several times. If you have a fraction, a over b equals 0, then your a must be 0, but your b cannot be 0. Why? Because we cannot divide by 0. And always 0 over any number, you get 0. That's the reason. If you have a fraction, take whatever I have up, which is 24, 1 minus x squared equals 0. If I solve this one for x, what do you have? Divide by 24. So you have 1 minus x squared, 0 over 24. What did you get? You get 0. So 1 minus x squared equals 0. So 1 equals x squared. So what is your x? Your x here is plus or minus square root of 1. So which is your x here plus or minus 1. Or just you factor out, you get plus or minus 1. You have two value plus or minus 1. So is this inside the domain? Yes, inside the domain. What is the domain? What is the domain here, guys? Inside the domain, because the domain here is all real numbers. For this example here, minus infinity to plus infinity, right? So inside the domain, yes, inside the domain. So what is the last one here? I need to check the concavity here. So here is -1. Here is your 1. What happened for my second derivative? The sign here of second derivative. I look for the sign. Look what you have. You don't need to get the value, but the sign of your second derivative. How to get the sign of your second derivative? Let me show you here the second derivative that you have. Equation 3. What do you know about this term, guys? Here, x squared plus 3 to the power 3, always positive. So the sign of this term, positive. 24 also positive. So I'm worried about 1 minus x squared. I'm worried about the sign of 1 minus x squared. What is the sign of 1 minus x squared? Here, very easy. Take x equals 0. Between 1 and negative 1, 0. If I wrote it here, this term is positive. Where? Here, positive. Maybe I use just a different color so that I show you. 24, it's positive number. This term, it's always positive. That's what I show you. So what you should worry about 1 minus x squared, the blue one. So that is the term that you should worry. If I replace x by 0, what did you get? 1 minus x squared. You get 1, which is positive, and here everything positive. So the sign of, when I replace x by 0, the sign here is positive. So the sign here is positive, so I write here positive sign. All right, so that is, I write here positive sign. So now take x equal negative 2, very easy, negative 2. Again, what do you have? 1 minus x squared. 1 minus x squared. If I replace x by negative 2 or plus 2, negative 2 or plus 2, you get negative 2 squared, which is 1 minus 4. 1 minus 4, you get, if I replace x by negative 2, you get negative 2 squared, which is, you get 1 minus 4, which is negative 3. So what is the sign of this? The sign of this is negative. So here I'm just write negative. So here positive means the graph is concave up. Negative means the graph is concave down. CD concave down. So now if I take x equal 2, so again you find it's what? Is negative 2. Is negative. Let me show you. Here 1 minus x squared. 1 minus x squared. This one. 1 minus x squared. If I replace x by 2, you get 1 minus 2 squared, which is 4. 1 minus 4, you get negative. Negative. So here the sign is negative. So the graph here is concave down. So what is the conclusion, guys? The conclusion here is negative 1 is inflection point? Yes. Is 1 here is inflection point? Yes. Those two. So what is my inflection point? Negative 1. So x. So the conclusion, negative 1 and 1 are inflection point, right? So negative 1 and 1, they are inflection point because the concavity here changed from concave down to concave up. Look what you have before negative 1, concave down to concave up, and from here at 1, concave up to concave down. So negative 1 and 1. So what do you have? You have concave up. So they are inflection point, yes. So now if I go to the graph, look what you have. So where is the graph is concave up here, guys? The interval concave up between negative 1 and 1. Where is the graph is concave down? From minus infinity to negative 1, and also from 1 to plus infinity. So from 1 to plus infinity is concave down. From minus infinity to negative 1 is concave down. So if I go back to the graph, that is the one here. So here the graph, maybe I use different colors. Maybe I use yellow. So here, look what you have at 1 here. I take this one here out. So the graph here is what? Before negative 1. At here you have the graph is concave down, right? Concave down. So here it's a concave down like this. Look what you have, concave down. So this one is the yellow one here is concave down. Look what you have, y equal 1 is what? Is horizontal asymptote, means your graph never cross or touch y equal 1. Your graph never cross or touch y equal 1. So that is the yellow one. And before 1 here also, again, it's also concave down. So here, look what you have. So I'm just graphic like this. So this one concave down. This one here is concave down. And then what happened for between negative 1 and 1, the graph is concave up. As you can see, the graph is concave up. So that is a graph very much we want. So before 1 is concave down. So that is I try to make concave down, and you have x-intercept, and here is concave up. So now some people can ask, in order to finish, what happened for this one when x equal negative 1 and 1? You said they are inflection point. So what is your y? Your y here is what? Is 0, guys. Your y. So the inflection point negative 1 is, and y equals 0, and here, and 1 equal here 0. Why? Because that is negative 1 and 1, that is what? Our x-intercept. If you recall, okay, x-intercept. So in order to show you this, okay, let me show you. So that is, we have seen that before, that is our x-intercept. How did I get x-intercept to 1 and negative 1? When I put y equals 0. When I put y equals 0. So the value here is 0. So that is the reason when you go for the graph, where is the graph here? Here, this one, your y is 0. So here, inflection point negative 1 and 0. And here is 1 and 0. 1 and 0 here, right? Or if you go for equation 1, if I replace x by 1, you get 0. Look what you have. If you replace, where is equation 1? Here, x squared minus 1. If I replace x by 1, you have 1 minus 1, which is 0. If I replace x by negative 1, you have negative 1 squared minus 1 equals 0. Then we are done. That's very much our sketching the graph. So let me summarize. I think I took a long time here, but I'm just reviewing very much all the material. So I start, how did I start? I figured out the domain. I figured out where is the graph is x-intercept, y-intercept. Do we have a vertical asymptote or horizontal asymptote? And then I apply first derivative test to find all critical point, and then I put it on in the plot. And then I have to find the inflection point. Where is the graph concave up, concave down? I put it on the graph, then you are done. All right, so that's very much here, guys, what I have done. Okay, I will stop here, and then I will see you for next class. Thank you.